There is a silence between the stars that is more than just the absence of sound. It is a fundamental disconnection, a vast and indifferent gap that separates every island of matter in the cosmos from its neighbor. When you look up at the night sky and fix your gaze on a distant point of light, you are not seeing the universe as it is. You are seeing a ghost. You are witnessing a history that has already crumbled to dust. The photon striking your retina left its source 1,000 years ago, or 1,000,000, or perhaps before the Earth itself had cooled from molten rock. We live in a universe of lag, where the present moment is a lonely island, forever cut off from the real, time reality of the cosmos. This isolation is enforced by a single unyielding law. It is a number that is etched into the bedrock of existence, deeper than gravity, or deeper than matter, deeper than time itself. 290, 9,790, 2,450, 8 meters per second. The speed of light. For over a century, physics has declared this speed to be the absolute speed limit of the universe. It is not merely a regulation that can be broken with a fast enough engine or a powerful enough fuel source. It is a wall. Einstein's equations built an unbreakable fortress around the concept of causality, ensuring that no signal, no object, and no information could ever outrun the beam of a flashlight. Nothing moves faster than light. Case closed. This barrier has defined the boundaries of human ambition. It tells us that the stars are not destinations, but merely decorations, forever beyond our reach in any human lifespan. But what if this wall is not solid? What if the barrier that Einstein discovered was not a ceiling, but a door that we simply haven't learned how to open? To understand why scientists are now beginning to whisper about breaking this limit, we must first understand why the limit exists at all. It is not an arbitrary number chosen by a cosmic architect. It is the result of the geometry of the space we occupy. For most of human history, we believed that space was a passive stage. It was an empty box, a void of nothingness where planets spun and stars burned. In this old Newtonian view, time was a steady drumbeat, ticking away at the exact same rate for a king in London, a monk in Tibet, and a star on the edge of the galaxy. 1 second was 1 second, everywhere and forever. Speed was simple. If you run at 10 miles an hour on a train moving at 50 miles an hour, or you are moving at 60 miles an hour relative to the ground, velocities simply added up. It made intuitive sense. It matched everything our ancestors experienced for thousands of years. But in 1905, a young patent clerk in Bern, Switzerland, peered into the mathematics of electromagnetism and realized that this intuitive world was a lie. Albert Einstein saw a contradiction that would dismantle the old universe. He noticed that light did not behave like a train or a runner. If you chased a beam of light at 99% of its speed, intuition says the light should only be inching away from you. But the experiments showed something impossible. No matter how fast you chase a photon, it recedes from you at exactly the same speed. You can never catch up. You can never close the gap. The speed of light is constant, is regardless of the observer. This single realization broke the concept of absolute time. If the speed of light must remain the same for everyone, then something else has to give. That something turned out to be reality itself. Einstein revealed that space and time are not rigid. They are flexible. They are a single interwoven fabric called spacetime. In order to keep the speed of light constant, the universe distorts the very measurements of distance and duration. As an object accelerates, moving faster and faster through space, it begins to trade its movement through time for movement through space. A clock on a spaceship moving near the speed of light ticks slower than a clock resting on Earth. This is not a mechanical error. It is time itself dilating, stretching out like taffy. The faster you move, the heavier you become. This is the Great Barrier. The energy required to accelerate an object increases exponentially as you approach the speed limit. To push a single electron to the speed of light would require infinite energy. Not just the energy of a star or a galaxy, but more energy than exists in the entire observable universe. The math creates a vertical wall. As velocity climbs, mass climbs with it, becoming infinitely heavy at the threshold. This asymptotic curve suggests that faster than light travel is not just difficult, it is a physical absurdity. It is like trying to go north of the North Pole. The geometry simply does not allow it. The universe effectively protects its speed limit by making the cost of breaking it infinite. But the energy barrier is only the first line of defense. There's a second, a darker reason why the cosmos forbids superluminal travel, one that deals with the sanity of existence itself. The speed of light is often misnamed. It should be called the speed of causality. It is the maximum speed at which one event in the universe can influence another. If you were to travel faster than light, you would be out-Han-Fosing the cause of your own departure. You would be moving into a realm where the sequence of events dissolves. In the framework of special relativity, faster than light travel is equivalent to time travel. If you could send a signal faster than light to a distant star, and they bounced it back faster than light, the reply could arrive before you sent the original message. You could receive the answer to a question you haven't asked yet. This violation of causality creates paradoxes that threaten the logical structure of reality. The universe appears to be designed specifically to prevent these paradoxes from arising. The speed limit is the guardian of history, ensuring that the past remains settled and the future remains unwritten. For decades, this seemed to be the final word. We were trapped in our local bubble of causality, condemned to look at the stars but never touch them. Humanity resigned itself to the slow lane, accepting that interstellar travel would require generation ships, vast arcs drifting for thousands of years across the void. But physics is a restless discipline. It does not accept impossible without looking for the fine print. And in the fine print of Einstein's greatest work, General Relativity, a loophole was found. While special relativity governs objects moving through space, general relativity describes the behavior of space itself, and this distinction changes everything. Special relativity says that nothing can move through the fabric of space faster than light. The fabric is the road, and light speed is the maximum velocity for any car on that road. But general relativity reveals that the road itself is not static. The fabric of spacetime can expand, contract, twist, and bend. And here lies the critical realization there is no limit on how fast space itself can move. We see this in the cosmos today. The universe is expanding. Galaxies far away from us are receding at speeds that technically exceed the speed of light. They are not breaking the law because they are not moving through space. The space between us and them is stretching. The creating new distance faster than light can cross it. This observation lit a fire in the minds of theoretical physicists. If the universe can expand space faster than light, could we artificially generate this effect? Could we build a machine that does not move through space, but instead forces space to move around it? This is the foundational question of the warp drive. It is not an engine in the traditional sense. It does not burn fuel to create thrust. It is a manipulation of geometry. The idea implies a technology that grabs the fabric of the vacuum and crumples it, pulling a distant destination closer while pushing the starting point away. The ship would sit inside a bubble of flat, calm space, feeling no acceleration, no g forces, and no time dilation. To the passengers, the ship is stationary. It is the universe that is moving. The concept remained a staple of science fiction, a narrative convenience to get characters from one plot point to another until 1994. In that year, a Mexican theoretical physicist named Miguel Alcubierre took the equations of general relativity and decided to solve them in reverse. Instead of asking what geometry a mass would create, he defined the geometry he wanted: a bubble of warped space moving faster than light, and asked the equations what kind of energy would be needed to create it. The result was a valid mathematical solution, the Alcubierre metric. It was a shock to the scientific community because it proved that, theoretically, the laws of physics do not forbid warp drives. The math allows it, but the universe resists it. The Alcubierre solution came with a price tag that seemed impossible to pay. To make space contract in front of a ship and expand behind it, you need to manipulate gravity in a way that normal matter cannot. Normal matter stars, planets, you, me, has positive mass. It creates attractive gravity. It pulls space together. But to expand space behind the ship, to push the universe away, you need repulsive gravity. You need a substance that creates a geometry opposite to that of a black hole. You need negative energy. Negative energy is not merely antimatter, which has positive mass. Negative energy is something far more exotic. It is a region of space where the energy density is lower than the vacuum itself. It implies a substance that weighs less than nothing. If you had a ball of negative energy and pushed it, it would move towards you. It defies every intuition we have about the physical world. For a long time, it was believed that negative energy was a mathematical fiction, a phantom that could not exist in reality. But quantum mechanics suggests otherwise. We have observed the Casimir effect, a phenomenon where two metal plates placed microscopically close together create a tiny, measurable negative pressure between them. The vacuum of space is not empty. It is seething with virtual particles popping in and out of existence. By restricting these fluctuations, we can create pockets of negative vacuum energy. So the ingredients exist, but the quantity required by Alcubierre's original calculation was staggering. To build a warp bubble just a few meters across, you would need a mass of negative energy equivalent to the mass of the entire observable universe. The proposal was mathematically sound, but energetically impossible. It was a blueprint for a machine that could never be built. The door that Alcubierre opened seemed to slam shut immediately. However, the theoretical physics community did not give up. Over the last 3 decades, they have been whittling down that energy requirement, optimizing the shape of the bubble, thickening the walls, finding geometric efficiencies. They brought the requirement down from the mass of the universe to the mass of a galaxy, then to the mass of a sun, and eventually to the mass of a planet. Yet, even a planet's worth of negative energy is an impossible ask. We can barely generate a few joules of it in a lab. The dream of the warp drive seemed destined to remain a mathematical curiosity, a beautiful equation with no physical counterpart, until very recently. A shift has occurred in the research. A new generation of physicists has begun to ask a different question. Is negative energy actually necessary? Or have we just been looking at the equations the wrong way? New papers published in the 2020s are challenging the assumption that exotic matter is the only way to warp space. They are proposing classes of solitons waves of spacetime that could theoretically be constructed from positive energy. Ordinary mass. The stuff we have. This potential breakthrough shifts the conversation from impossible to merely extremely difficult. If a warp field can be generated by configuring normal matter in complex, ultra-dense arrangements, then the barrier is no longer fundamental. It becomes an engineering problem. But as we strip away the energy barrier, we find other monsters lurking in the math. The universe defends its speed limit with layers of traps. Even if we could build the bubble, how do you survive inside it? Imagine a ship traveling inside a warp bubble. The space in front of the bubble is contracting, collapsing light, years of distance into millimeters. The space behind is expanding. The ship sits in the eye of the hurricane. But there is a problem known as the horizon problem. Because the bubble is moving faster than light, the front wall of the bubble is causally disconnected from the ship inside. You cannot send a signal to the front of the bubble to tell it to steer or stop or slow down. The signal would travel at the speed of light, but the bubble wall is moving faster. The signal would never reach the engine. You would be trapped in a runaway train, blind and deaf to the universe outside. She unable to control your own trajectory. Furthermore, the bubble itself interacts with the interstellar medium. Space is not truly empty. It is filled with thin gas, cosmic dust, and radiation. As the warp bubble smashes through this medium at superluminal speeds, it sweeps up these particles. They accumulate on the front wall of the bubble, trapped in the gravitational distortion. The energy of these trapped particles grows higher and higher the longer you travel. They are compressed and heated to unimaginable levels. When the ship arrives at its destination and the bubble is turned off, that accumulated energy has to go somewhere. Theoretical models suggest it would be released in a focused beam of gamma rays and high-energy particles, blasting directly forward. You wouldn't just be arriving at a new planet, you would be effectively firing a death ray at it the moment you stopped. The act of stopping the ship could sterilize the world you came to explore. These are the nightmares that keep physicists awake. The universe seems to have installed fail-safes. Every time we find a way to cheat the speed limit, a new catastrophe appears in the equations. It is as if reality itself is fighting to preserve the order of cause and effect. And yet, the allure is too strong to ignore. We are a species defined by our refusal to accept boundaries. We look at the silence between the stars, and we do not see a wall, we see a challenge. The search for a functional warp drive is more than just a quest for speed. It is a quest to understand the source code of reality. To manipulate the metric of spacetime is to touch the very clay from which the universe is sculpted. We are probing the limits of general relativity, looking for the seams where the theory might fray, revealing a deeper truth underneath. We are looking for a way to break the silence. And while the Alcubierre drive in its original form may be impossible, the thinking it sparked has led us down a rabbit hole of new physics. We are now exploring the concept of warp shells, gravitational pipelines, and the quantum nature of the vacuum itself. What we are finding is that the universe is far more malleable than Newton ever imagined, but far more protective of its structural integrity than Alcubierre hoped. We are standing on the precipice of a new understanding of gravity. The question is no longer, can we go faster than light? The question is, what happens to the universe if we do? The answer might be hidden in the microscopic jitter of the quantum vacuum or in the crushing gravity of neutron stars. It is a detective story written in the language of tensors and differential geometry. As we delve deeper into this mystery, we must prepare ourselves for the possibility that the speed limit is absolute, that the silence is eternal. But we must also entertain the terrifying, exhilarating possibility that the lock can be picked, that the door is heavy but it is not sealed, and if we can open it, even just a crack, the entire history of our species and the future of life in the cosmos changes in a single heartbeat. The journey to understand this mechanism takes us to the edge of known physics, where intuition fails and only the math remains to guide us through the dark. This is the story of the barrier that defines us and the dream of the engine that could set us free. To understand the true magnitude of the challenge, we must stop thinking of space as nothing. This is the first mental hurdle that prevents us from grasping the mechanism of a warp drive. We are conditioned to view space as a void, a lack of substance, a mere container where things exist. But in the equations of general relativity, space, or more accurately, spacetime is a substance. It has properties, it has texture, it has resistance, it can be stiff, and it can be fluid. It is a physical medium that connects every point in the universe to every other point. When we talk about warping space, we are talking about manipulating a physical reality that is billions of times stiffer than steel. Physicists often use a term called the stiffness of spacetime to describe how difficult it is to curve. The formula involves the speed of light to the fourth power divided by the gravitational constant. Without getting lost in the arithmetic, the result tells us something humbling. Spacetime is incredibly rigid. It wants to stay flat. It resists curvature with a stubbornness that dwarfs any material structure we have ever engineered. To bend it even a fraction of a degree requires the mass of a moon or the energy of a star. This is why gravity is such a weak force on the human scale. You, with your entire body's mass, are warping spacetime right now, but the effect is so infinitesimally small it is negligible. To create a warp bubble, we are not asking to gently bend this stiff fabric. We are asking to crumple it like a piece of paper, to compress it violently in one direction and stretch it violently in another. The Alcubierre metric describes a specific topography of this violence. Imagine the spacetime around a spaceship not as a flat sheet, but as a frozen ocean. The ship sits on a patch of ice that is perfectly flat. It feels no motion, but ahead of the ship, the ice is melting and sinking, creating a deep pit. Behind the ship, the ice is expanding, erupting upwards like a geyser, creating a new mountain. Gravity works by objects falling along the curvature of space. In this configuration, The ship is perpetually falling into the pit ahead of it, but the pit moves. The ship is surfing a continuous wave of falling geometry. This creates a bizarre paradox for the occupants. If you were sitting in the captain's chair of a ship inside an Alcubierre bubble, traveling at 10 times the speed of light, your coffee would not spill. You would not feel being pressed back into your seat. Your instruments would tell you that your velocity relative to the space immediately around you is zero. You are effectively stationary. Yet, if you looked out of a side window assuming light could penetrate the distortion, you would see stars streaking by at impossible speeds. You are a stationary object in a moving universe. This is the elegance of the warp drive. It bypasses Newton's laws of inertia. Since you are not accelerating through space, you do not experience the crushing G, forces that would turn a human body into jelly if you tried to accelerate to light speed in a conventional rocket. However, the view from inside the bubble would be terrifying. As the bubble accelerates, the light coming from the stars ahead of you would be compressed, shifted towards the blue end of the spectrum, then into ultraviolet, then into X rays, and finally into high-energy gamma radiation. The view ahead would become a blinding, lethal point of invisible fire. Behind you, the light from the stars would be stretched, reddened, and shifted into infrared and radio waves, eventually fading into absolute blackness. You would be flying between a blinding radiation source ahead and an infinite void behind. And then, there is the silence. The isolation of the warp bubble is not just poetic, it is physical. We touched upon the horizon problem, but it requires a deeper examination because it represents perhaps the most stubborn engineering hurdle of all. When the warp bubble moves faster than light, it creates an event horizon similar to that of a black hole. Information cannot travel faster than light inside the bubble. If the front wall of the warp bubble is 10 kilometers away from the ship and the bubble is moving at twice the speed of light, any signal you send to the front wall will never get there. You are chasing a horizon that recedes faster than your message can travel. This implies that the crew inside the bubble is completely helpless. They cannot steer the ship. They cannot throttle the engine. They cannot turn the drive off. The mechanism that generates the warp field, the engine, would presumably be on the ship, but the field itself extends out into the region that is causally disconnected. How do you tell the space 10 kilometers ahead of you to contract if your signal cannot reach it? Some theorists have proposed that we would need to lay down the tracks for the warp drive in advance, sending out a slower-than-light drone to prepare the geometry of space before the ship arrives. But this defeats the entire purpose of a faster-than-light drive. If you have to pave the road at sub-light speeds before you can drive on it, you haven't really solved the problem of exploration. You are just building a very fast train on a very slow construction schedule. There is another, more subtle horror hidden in the geometry. It concerns the thickness of the bubble walls. In Alcubierre's original paper, the walls of the warp bubble, the region where space is actually being distorted, were very thin. But quantum mechanics hates sharp edges. The Heisenberg uncertainty principle suggests that you cannot define the position and momentum of the energy field with perfect precision. If you try to make the bubble walls too thin, the energy requirements skyrocket towards infinity again. If you make them too thick, the tidal forces inside the bubble, the difference in gravity between your head and your feet, might become strong enough to rip the ship apart. There is a Goldilocks zone where the bubble is thick enough to be energetically cheaper, but thin enough to be safe for the crew. Finding this zone is a balancing act that requires a unified theory of quantum gravity, a theory we do not yet possess. We must return to the fuel, the negative energy. It is easy to say negative energy and move on, but we must appreciate how deeply this concept violates our understanding of the universe. In classical physics, energy is always positive. Mass is positive. You cannot have a pile of apples with -5 apples in it. But in the warped geometry of the Alcubierre drive, the energy density must drop below zero. This is not just a vacuum, it is a sub-vacuum. We mentioned the Casimir effect as a proof of concept, but the scale is the issue. The Casimir effect produces negative energy density on the scale of atoms. It is fleeting, unstable, and incredibly weak. To sustain a warp bubble, we need macroscopic amounts of this stuff. we need to dredge up the seabed of the universe and dig a hole in reality. Some physicists have speculated that we might be able to use quantum inequality loopholes, tricking the vacuum into giving us a loan of negative energy that we have to pay back later. But the interest rate on that loan is extremely high. The longer you want to sustain the bubble and the larger you want it to be, the harder the universe fights to snap back to zero. It seems the cosmos has a built-in credit limit on negative energy. This reliance on unobtainium, a material that may not exist in useful quantities, led many to declare the warp drive dead on arrival. It was a nice math trick, they said, but physically impossible. For 25 years, this was the consensus. The Alcubierre drive was a phantom, a ghost story told by General Relativity to haunt engineers. But in 2020 and 2021, the narrative shifted. A sudden burst of theoretical papers appeared that changed the variables. Physicists like Erik Lentz and the team of Bobrick and Martyr proposed a radical new idea. What if we don't need negative energy at all? What if we have been trying to build the wrong shape? Lentz's paper was a bombshell. He analyzed the field equations and found a new class of solutions called hyper-fast solitons. He discovered that if you arrange ordinary positive mass energy in a very specific, complex geometric pattern resembling a plasma woven into a fractal, like structure, you could theoretically create a warp bubble without violating the energy conditions. You didn't need exotic matter. You didn't need to dig a hole in the vacuum. You just needed an astronomical amount of normal energy, arranged with absolute precision. This shifted the problem from impossible physics to impossible engineering. We know how to make positive energy, we just don't know how to pack the mass of Jupiter into a ship the size of a bus and keep it stable. But impossible engineering is a hurdle that humanity has cleared before. We went from wooden gliders to the moon in 60 years. The shift from negative energy to positive energy moved the warp drive back into the realm of the physical. The Bobrick and Martyr paper took this further. They classified warp drives not as engines, but as objects moving through space. They showed that a warp drive is essentially a shell of matter. If you are inside the shell, time flows at a different rate than if you are outside. They demonstrated that you could have a slow warp drive, a bubble that moves slower than light, but still offers the benefits of weightlessness and inertia, less propulsion. This was a crucial step. It meant we could test the technology without breaking the universe. We could build a prototype that travels to Mars in days rather than months, without ever approaching the speed of light barrier. However, these positive energy solutions came with their own catch, and it is a catch that brings us back to the sentinel of causality. The new equations suggest that while you can maintain a warp bubble with positive energy, you cannot accelerate it past the speed of light with positive energy. A sub-light warp drive is possible. A super-light warp drive is mathematically consistent. But the bridge between them is broken. You cannot accelerate from 0.5 c to 1.5 c without crossing the barrier. And crossing the barrier seems to require that forbidden negative energy or a violation of continuity. It creates a scenario where superluminal warp bubbles might exist, but they would have to be eternal. They would have to have existed since the Big Bang, flying through the universe forever. You could theoretically hitch a ride on one if you caught it, but you couldn't build one from scratch and accelerate it from a standstill. This leads to the tachyon problem particles that always move faster than light, but can never slow down. Are we chasing a geometry that can only exist if it has always existed? This brings us to the edge of the map. We have the math for the vehicle, but we lack the ignition key. And looming over all of this is the question of time. We cannot escape the fact that in relativity, space and time are the same thing. If you warp space, you warp time. When we talk about traveling to Alpha Centauri in a few days, we are effectively talking about a time machine. If you travel faster than light, there are reference frames, valid points of view in the universe where you arrive at your destination before you left Earth. This is not an optical illusion, it is a breakdown of the sequence of reality. Stephen Hawking famously proposed the chronology protection conjecture. He argued that the laws of physics conspire to prevent time travel on a macroscopic scale. He believed that if you tried to build a time machine or a warp drive that acted like one, the universe would trigger a reaction to destroy it. In the case of the warp drive, this reaction comes from the vacuum itself. Calculations done in the semi-classical limit suggest that as a warp bubble approaches the speed of light, the quantum fluctuations at the front edge of the bubble begin to amplify. The vacuum starts to scream. The virtual particles, usually harmless, are boosted to infinite energy densities. The moment you try to cross the threshold, the vacuum friction creates a wall of energy that vaporizes the ship. The universe effectively detonates the road to prevent you from speeding. This instability is the universe's immune system response. It detects a violation of causality, a potential paradox, and it sterilizes the infection. This implies that the speed of light is not just a limit on motion, but a limit on the structural stability of existence. To break it is to risk unraveling the fabric that holds the timeline together. So where does that leave us? Are we trapped in a prison of radius 13.8 billion light years, condemned to watch the galaxies drift away into the dark? Not necessarily. The fight between general relativity, which allows the warp, and quantum mechanics, which forbids the instability, is not over. These two theories are notoriously incompatible. We know they are both approximations of a deeper truth. General relativity works perfectly for stars and galaxies. Quantum mechanics works perfectly for atoms and particles. But when we try to combine them as we must in the high-energy environment of a warp bubble, the math breaks down. We get nonsense answers. This nonsense is the gap where hope lives. It is in this gap that a theory of quantum gravity must exist. String theory, loop quantum gravity, and other exotic frameworks are attempting to bridge this divide. It is possible that in a full theory of quantum gravity, the instability vanishes. It is possible that the universe has a safe mode for FTL travel that we haven't discovered yet, because we are looking at the problem with incomplete tools. We are like 19th century engineers trying to understand nuclear fusion using steam engine parts. We can see the sun, we know it produces vast energy, but our theories of coal and fire cannot explain it. We are missing the fundamental component. For the warp drive, that component is the quantization of gravity. Until we unlock that final door, we are left with the working theories. We have the Alcubierre metric, a beautiful but hungry beast. We have the Lentz solitons, massive and clumsy but physically grounded. We have the sheer, unyielding silence of the stars, challenging us to come closer. The story of the warp drive is not a story of a failed invention. It is a story of a species trying to negotiate the terms of its confinement. We are pulling on the bars of our cage, testing their strength, looking for a rusted hinge, a loose screw, a weakness in the design. And there is one more possibility, one that is perhaps the most intriguing of all. It involves looking not at the ship but at the destination. If we cannot move the ship to the star, can we move the star to the ship? Or, more accurately, can we fold the space so that the distance itself becomes irrelevant, not by surfing a wave, but by piercing the veil? This leads us away from the warp drive and towards its darker, more violent cousin, the wormhole. The Einstein-Rosen bridge. While the warp drive is a surfboard, the wormhole is a tunnel. It does not require moving faster than light locally. It requires changing the topology of the universe. It requires punching a hole in the paper and connecting two distant points. Interestingly, the mathematics of warp drives and wormholes are deeply connected. They both require similar exotic conditions to stay open, but a wormhole offers a different set of paradoxes and a different set of dangers. If the warp drive is a loud, energy-guzzling attempt to brute force the speed limit, the wormhole is a subtle subversion of the geometry. But like the warp drive, it is guarded by the same sentinels: negative energy, stability, and the chronology protection conjecture. The universe is consistent in its obstructions. As we stand here, at the beginning of the 21st century, looking at equations that suggest we could reach the stars, we are faced with a choice. Do we accept the speed of light as the final horizon, the edge of the petri dish? Or do we trust the math that says there is a way out? The fact that we can even formulate the question that we can write down a metric for a warp drive is a profound statement about the human mind. We are creatures of matter, evolved to hunt and gather on a small, wet rock, yet we have developed a language that can describe the curvature of the cosmos. Perhaps the very existence of the Alcubierre solution is a hint, a breadcrumb left by the laws of physics. It tells us you are not thinking big enough. The energy of Jupiter, the mass of the sun, these seem impossible to us now, but to a caveman, the energy of a nuclear reactor would have seemed like the power of a god, impossible to harness. Impossible is often just a word for we don't know how yet. But before we can build the engine, we must survive the physics. We must solve the riddle of the horizon, finding a way to steer the blind ship. We must solve the riddle of the radiation, finding a way to arrive without destroying the destination. And we must solve the riddle of the paradox, finding a way to travel without unmaking the past. The night sky is waiting. The silence is deep. But in the laboratories and on the blackboards of universities around the world, the sound of chalk scraping against slate is the sound of humanity picking the lock. The warp drive is not just a dream of speed, it is a dream of contact. It is the refusal to be alone. And as long as the equations offer even a sliver of a chance, we will keep writing them, keep testing them, keep pushing against the dark. Because the alternative to remain forever isolated on this single island of life is a fate we are not yet ready to accept. For 25 years, the Alcubierre drive stood as a monument to human imagination and a tombstone for human ambition. It was the ultimate yes, but yes, you can travel faster than light, but only if you possess a substance that does not exist. The requirement for negative energy, that ghostly, impossible fuel, became a dogma in the physics community. It was the accepted wisdom that if you wanted to bend space in a way that allows for superluminal travel, you had to violate the energy conditions of the universe. You had to cheat. And because nature generally does not allow cheaters, the warp drive was relegated to the shelf of impossible things, gathering dust alongside perpetual motion machines and cold fusion. But science is not a static monolith. It is a living, breathing process of re-examination. In the early years of the 2000s, while the world was distracted by terrestrial crises, a quiet revolution began in the pages of theoretical physics journals. A handful of researchers began to look at the Alcubierre metric not as the final answer, but as a rough draft. They asked a question that had been largely ignored for a quarter of a century. Is the need for negative energy a fundamental requirement of warping space, or is it just a side effect of the specific, simple shape that Miguel Alcubierre chose in 1994? Alcubierre's original bubble was geometrically simple. It was a sphere. It was elegant, symmetrical, and clean. But often in physics, simplicity comes at a cost. To maintain that perfect, simple spherical geometry, the universe demanded the impossible payment of negative energy. However, recently, physicist Erik Lentz and a separate team comprising Alexei Bobrik and Gianni Martire decided to abandon simplicity. They plunged into the chaotic, messy, complex potential of the field equations. What they found was a revelation that shattered the negative energy dogma. They discovered that if you are willing to construct a warp field with a vastly more complex internal geometry, not a simple smooth sphere, but a twisted fractal-like structure of spacetime plasma, you can achieve the warp effect using only positive energy. This moment marked the most significant shift in propulsion physics since the dawn of the rocket age. It meant that the unobtainium barrier was gone. We no longer needed a substance that weighs less than nothing. We no longer needed to violate the known laws of quantum mechanics. We could, in theory, build a warp drive out of the same stuff that makes up a star, a planet, or a ham sandwich. The problem shifted instantly from a question of impossible physics to a question of impossible engineering. And while impossible engineering is daunting, it is a challenge that humanity understands. To grasp how this works, we must visualize the difference between the old Alcubierre drive and these new positive energy solitons. The Alcubierre drive was like a magic carpet. It required a material that levitated by defying gravity. The new soliton solutions are more like a tank. They are heavy, they possess mass, they obey gravity. but they are arranged in such a specific, hyper-dense configuration that their own gravitational field creates the propulsion. Lentz's work involved exploring hyperbolic geometric relations, a different family of mathematical shapes that had been overlooked. He found that by organizing the energy in a series of extremely dense waves, arranged in a specific lattice structure, the resulting space-time curvature would propel the bubble forward without needing to expand space using negative energy. It pushes off the fabric of spacetime using sheer gravitational mass, organized in a self-reinforcing wave. This wave is known as a soliton. In fluid dynamics, a soliton is a wave that holds its shape as it travels, refusing to disperse or fade out. A tsunami is a type of soliton. In the context of general relativity, a gravitational soliton is a packet of curved spacetime that holds itself together as it moves. The ship inside this soliton would be carried along not by magic, but by the gravitational momentum of the shell surrounding it. Bobrick and Marder took this analysis even further by formalizing the physics of warp shells. They demonstrated that a warp drive is essentially a vessel made of matter that modifies the spacetime inside it. They showed that there is a continuous spectrum of these shells. You can have a shell that moves slowly, creeping along at a fraction of light speed. Inside, time would pass at a different rate than outside. The passengers might age slower or faster than their families on Earth, depending on the mass and density of the shell. This realization that slow warp drives are possible is ground-breaking. It means we could test the technology without needing to break the light, speed barrier immediately. We could build a subliminal warp drive, a prototype that travels at 10% of the speed of light. Such a device would still be revolutionary. It would allow for rapid transit within our solar system, turning months-long journeys to Mars into weekend trips, all without the passengers feeling a single g force of acceleration. They would float in the zero, gravity calm of the bubble's interior, while the shell around them manipulated the metric of space to move them. It would be the ultimate luxury liner of the cosmos, a vessel where the engine is the hull itself. But the goal is not Mars. The goal is the stars. And here, the positive energy solutions run into a new formidable wall. The catch, 22 of positive energy. While the math proves that a positive energy bubble can exist and move faster than light, it does not explain how to get it there. In the Alcubierre model, the negative energy effectively allowed the bubble to have a negative mass effect, which made acceleration theoretically effortless. But a positive energy soliton has mass, enormous mass. To accelerate a structure with the mass of a planet up to the speed of light requires, once again, infinite energy. This creates a bizarre paradox. The equations allow for a positive energy warp drive to be moving faster than light, but they do not allow it to accelerate to that speed from a standstill. It is like discovering that a certain type of airplane can fly at Mach 10, but it cannot take off. It can only exist if it is already flying at Mach 10. These solutions divide the universe of warp drives into two distinct classes, the subliminal and the superluminal. The wall between them is the speed of light, and the positive energy equations provide no bridge to cross it. If you build a ship with positive energy, you are trapped in the slow lane. You can get arbitrarily close to the speed of light, but you cannot cross the threshold. To have a superluminal positive energy soliton, it would have to be created already moving faster than light. This implies a tachyonic origin. Tachyons are hypothetical particles that exist only at speeds faster than light. They cannot slow down. If such a warp bubble were to exist, it would have to be formed by some cataclysmic high-energy event that birthed it directly into a superluminal state. It suggests that these warp bubbles might not be vehicles we can build and launch from a spaceport. They might be cosmic trains that have been running since the Big Bang. Imagine a network of these gravitational solitons, ancient waves of geometry rippling through the galaxy at 10 times the speed of light. If we wanted to use them, we couldn't build one. We would have to catch one. We would have to detect a passing soliton, accelerate our ship to as close to light speed as possible, and then perform a trans-orbital injection into the bubble as it flew past. It would be the most dangerous maneuver in the history of existence. Jumping onto a moving train is dangerous. Jumping into a patch of spacetime that is moving faster than causality is a level of risk that defies quantification. And even if you manage to get inside, how do you get off? The soliton cannot slow down. It is eternally superluminal. To exit, you would have to jump out of the bubble, instantly decelerating from faster, then light to slower, then light. The tidal forces at the boundary would likely tear the ship down to its subatomic components. Furthermore, even if we solve the acceleration problem, perhaps finding a way to tunnel through the light speed barrier, the energy requirements for these positive energy drives remain astronomical. Lentz's initial calculations, while liberating us from negative energy, still required an amount of mass, energy equivalent to hundreds of Jupiter masses to create a bubble just a few meters across. We are talking about taking the entire mass of the largest planet in our solar system, compressing it into a shell the size of a house, and spinning it at relativistic speeds. This is not engineering as we know it. This is stellar architecture. It requires the ability to manipulate matter at densities found only in the cores of neutron stars. To build such a device, we would need to master the strong nuclear force, the force that binds atomic nuclei together. We would need to create dense matter composites that are stable outside of a star's core. We would need to generate magnetic fields billions of times stronger than anything produced on Earth to contain and shape this plasma shell. The heat generated by such a structure would be blinding. A ship like this would shine brighter than the sun. It would not be a stealthy craft slipping through the void. It would be a radiant beacon, a star, ship in the literal sense, a ship made of star stuff. Yet, despite these gargantuan challenges, the psychological shift in the scientific community has been profound. Impossible is a word that stops research. Expensive and difficult are words that stimulate it. The shift to positive energy means that we can now use supercomputers to model these drives. We can simulate the behavior of high-density plasma shells. We can look for warp effects in extreme astrophysical environments. It turns the galaxy into a laboratory. We can look at pulsars and magnetars and ask, are they generating natural warp solitons? Are there naturally occurring bubbles of geometry that we could study? This line of thinking leads to a fascinating hypothesis. If advanced civilizations exist, and if they have mastered this physics, their ships would not look like the metallic craft of our science fiction. They would look like small, moving stars. They would be incredibly dense, incredibly bright, and they would possess gravitational fields that would disrupt the orbits of any planets they passed. A positive energy warp drive is a gravitational monster. If one were to fly through our solar system, even at a safe distance, its gravity could disturb the asteroid belt, flinging rocks towards Earth. It could induce tides on the sun. The passage of such a vessel would not be a silent event. It would be a gravitational catastrophe for anything nearby. This brings us back to the Fermi paradox. If the universe allows for these positive energy engines, why haven't we seen them? A civilization capable of building them would be moving Jupiter, mass objects around. This is not subtle activity. It is loud. It is violent. The absence of these gravitational wakes in our astronomical data suggests that perhaps the barrier is not just about fuel. It suggests that even with positive energy, there is something else preventing the construction of these devices. The answer may lie in the stability of the geometry itself. Lentz's solitons are mathematically valid. But are they stable? If you poke them, do they collapse? Early analysis suggests that these complex plasma structures might be incredibly fragile. A slight imperfection in the density of the shell, a minor fluctuation in the magnetic containment, and the entire structure could implode into a black hole. We might be dealing with a technology where the margin for error is literally zero. To build a warp drive is to balance a pencil on its tip, but the pencil is made of neutronium and the table is vibrating. This instability is the new demon. We have traded the ghost of negative energy for the demon of chaos. The universe seems to demand perfect order to allow for perfect speed. And the second law of thermodynamics, entropy, hates order. It wants things to decay, to mix, to break down. Maintaining the pristine fractal geometry of a positive energy soliton against the chaotic background of the universe might require an active control system of God-like complexity. A computer that can correct for quantum fluctuations in real time, adjusting the density of the shell atom by atom, nanosecond by nanosecond. And so, the positive energy revolution has not given us a blueprint for a ship. It has given us a map of a mountain range we have to cross. It has shown us that the peak is not unclimbable, but the air is thin, the path is steep, and the fall is lethal. We have moved from the realm of magic to the realm of the monumental. We are no longer asking for a miracle, we are asking for the ultimate mastery of matter and energy. We are asking to become the architects of gravity itself. The implications of this shift extend beyond propulsion. If we can manipulate positive energy to bend space this significantly, we can do more than just travel. We can build shields that deflect asteroids by curving space around the planet. We can build computers that operate in pockets of dilated time, performing millions of years of calculation in a single second. The warp drive is just one application of a much broader mastery of space-time geometry. We are standing at the threshold of the metric age, an era where we stop living in space and start shaping it. But for now, the speed limit holds. The positive energy drives are theoretical giants, trapped on the paper they were written on. They wait for a civilization bold enough and energized enough to forge the ring of dense matter that could unlock the sky. The silence remains, but the nature of the silence has changed. It is no longer the silence of an empty room, it is the silence of a vault, waiting for the right combination. And while the engineers dream of Jupiters compressed into hulls, the theoretical physicists have turned their eyes to the final, most subtle lock on the door. The one that deals not with energy or mass or stability, but with the arrow of time itself. The protection of history, the reason why the universe might destroy any machine that dares to outrun the present. The chronology protection conjecture. We have arrived at the final gate. The energy barrier has been challenged, the engineering hurdles have been mapped, and the navigation problems have been acknowledged. But there remains a ghost in the machine, a specter that haunts every equation describing faster than light travel. It is not a question of thrust or mass or fuel. It is a question of logic. To understand why the universe might violently forbid a warp drive, we must confront a truth that science fiction often conveniently ignores. Moving faster than light is, geometrically and inescapably, traveling backward in time. This is not a separate feature or a malfunction of the drive. It is a fundamental consequence of how space and time are woven together. In our intuitive daily lives, we imagine time as a universal river, flowing at the same speed for everyone. If it is Tuesday in New York, it is Tuesday in the Andromeda Galaxy. But Einstein shattered this clockwork reliability. He showed us that now is a relative concept. The slice of the universe that you consider to be the present moment depends entirely on your velocity. If you are standing still, your now cuts through space-time at a certain angle. If you start moving, that angle tilts. At low speeds, walking, driving, even flying in a jet, this tilt is microscopic. The difference in time is measured in nanoseconds, undetectable to human senses. But as you approach the speed of light, the tilt becomes extreme. Your definition of simultaneity diverges wildly from a stationary observer. Now, imagine you have a warp drive. You can travel faster than light. You decide to fly to a distant star and return. According to the rigorous geometry of special relativity, there exists a valid frame of reference, a specific speed and direction for an observer where you arrive back on Earth before you left. This is the closed time-like curve. It is a loop in history. It allows you to interfere with your own past. You could, in theory, walk up to your younger self as they are climbing into the spaceship and stop them from leaving. But if you stop them, you never took the trip. If you never took the trip, you never returned to stop them. So they do leave. This is the classic paradox, the logical cancer that threatens the consistency of reality. A universe that allows faster than light travel is a universe where causes can happen after their effects. It is a universe where the glass shatters before the bullet is fired. Physics, as a discipline, relies on the assumption that the universe makes sense, that the past determines the future, not the other way around. If causality breaks, the predictive power of science dissolves. To protect this order, the universe appears to have a defense mechanism. In 1992, Stephen Hawking formalized this suspicion into the chronology protection conjecture. He proposed that the laws of physics conspire to prevent the formation of closed time-like curves on a macroscopic scale. The universe, Hawking suggested, has a built-in immune system designed to keep the world safe for historians. But how does the universe enforce this law? It does not have a police force. It does not have judges. It has quantum mechanics. And the mechanism of enforcement is likely a catastrophic explosion of energy known as vacuum polarization. To visualize this, imagine a microphone placed right next to a speaker. If you make a sound, the sound goes into the microphone, out of the speaker, back into the microphone, and out of the speaker again. The loop repeats instantly, amplifying the sound each time until it becomes a deafening screech of feedback. This is an acoustic loop. A warp drive creates a temporal loop. But instead of sound, the thing that gets amplified is the quantum vacuum itself. The vacuum of space is filled with virtual particles, pairs of electrons and positrons that pop into existence and annihilate each other in the blink of an eye. Usually, they are harmless ghosts. But in the twisted geometry of a time machine, which is what a warp drive effectively is, these particles can get trapped in the loop. A virtual particle can emerge, travel around the loop, and return to its starting point at the same moment it left. It meets itself. It overlaps with its own past self. And then it goes around again and again and again, infinitely many times in a literal instant. The energy density of these piling up particles creates a quantum feedback screech. Except instead of noise, it is pure energy. Calculations suggest that as a warp bubble attempts to cross the threshold that would allow it to violate causality, the energy density of the vacuum fluctuations along the bubble's horizon spikes to infinity. This is the blue sheet. As you accelerate towards the speed of light, the vacuum radiation in front of you shifts into the blue, becoming more and more energetic. At the exact moment you attempt to cross the barrier, the radiation becomes infinite. The warp bubble is vaporized by the universe's own background noise. The drive is destroyed not by a mechanical failure, but by the fabric of reality refusing to allow the geometry to exist. The chronology protection conjecture suggests that the universe will destroy the machine to save the timeline. This leads to a chilling realization. The speed of light might not be a limit on velocity as much as it is a limit on history. The reason we cannot go faster than light is that the universe demands a coherent story. It demands that the beginning comes before the end. If we were to succeed in building a warp drive, we would be declaring war on this fundamental order. We would be trying to force the universe to accept a paradox. And the universe, seemingly, has the nuclear option: it burns the bridge before we can cross it. Some physicists argue that there might be exceptions. Perhaps the feedback loop is not infinite. Perhaps the energy defocuses or scatters before it destroys the ship. This is where the unknown realm of quantum gravity becomes our only hope again. We are using general relativity to build the stage and quantum mechanics to describe the actors, but we don't know the full script. It is possible that a fully unified theory would show that the feedback loop is self, limiting that the universe creates a mild radiation burn rather than a total vaporization. But even if the ship survives the vacuum explosion, the paradox remains. If you can travel FTL, you can send information back in time. Imagine a galactic internet where signals travel faster than light. You could receive a stock market tip from tomorrow. You could receive a warning about an accident that hasn't happened. This collapses the concept of free will and introduces deterministic chaos. If you know the future, can you change it? If you change it, where did the information come from? The warp drive, therefore, is not just a transportation device. It is a philosophy engine. It forces us to ask whether the future is already written or if it is being composed moment by moment. If the future is already written, if the universe is a block universe where all of time exists simultaneously, then perhaps FTL travel is possible because you cannot change the past. You can visit it, but your actions were always part of history. This resolves the paradox by removing our agency. We become puppets in a rigid, four-dimensional sculpture. But if the future is open, if our choices matter, then the speed limit must hold. The walls of our cosmic prison are the very things that give us the freedom to act. Without the speed limit, cause and effect decouple and action becomes meaningless. The silence of the stars, then, is the sound of a universe preserving its own sanity. There is also a thermodynamic cost to this chronology protection. Hawking's calculations often involved black holes and the event horizons that surround them. A warp bubble creates a similar horizon. The Hawking radiation that slowly evaporates a black hole would be incredibly intense for a small, superluminal bubble. The interior of the ship would be bathed in a thermal glow that rises in temperature as the velocity increases. Even if the vacuum feedback doesn't vaporize the ship instantly, the occupants might be slowly cooked by the quantum friction of passing through the timeline. We must also consider the sinking of the vacuum. Some recent theories suggest that attempting to warp space to this degree might trigger a phase transition in the vacuum itself. The vacuum we live in might be a false vacuum, a state that is stable but not the lowest possible energy state. If a warp drive concentrates enough energy in a small point, it could nucleate a bubble of true vacuum. This bubble would expand at the speed of light, destroying everything in its path, not just the ship, but the Earth, the solar system, and eventually the galaxy. The laws of physics inside the bubble of true vacuum would be different. Chemistry would not work. Atoms would not hold together. In this scenario, the warp drive is not just a suicide machine, it is a galactic doomsday device. The universe might prevent us from building it simply because the energy densities required are synonymous with the conditions needed to end the universe. It is a sobering thought. Perhaps the reason we didn't see starships zipping around is that any civilization that builds one accidentally deletes itself from existence shortly after. The great filter of the Fermi paradox might be the Alcubierre instability. However, human curiosity is resilient. For every paper proving the instability of warp drives, another paper is published searching for a loophole. We look for Cauchy horizons that are stable. We look for specific trajectories that avoid the feedback loop. We explore the idea of warp tubes, permanent tunnels in space that do not allow for time travel, because the endpoints are synchronized in a specific way. These tubes would be like cosmic highways, allowing fast travel between 2 points, but preventing the return trip from violating causality. You could go to Alpha Centauri for lunch, but you would have to accept that your now has shifted permanently. This concept of restricted FTL travel that is faster than light but constrained to prevent time paradoxes is the current frontier of the hope. It suggests a universe that is not a total prison, but a maze. There are paths we can take, but they are narrow, winding, and strictly one way in terms of causality. We might be able to cheat distance, but we can never cheat time. As we stare at the equations of the chronology protection conjecture, we are looking at the final boss of physics. It is the gatekeeper that stands between us and the galaxy. It tells us that we can have a coherent history, or we can have the stars, but we cannot have both. And yet, we push. We simulate. We calculate. Because deep down, we refuse to believe that the universe is a cage. We refuse to believe that the light from the Andromeda galaxy is a picture of a place we can never visit. We are searching for a way to have our cake and eat it too, to travel backward in time without breaking history, to move faster than light without causing a paradox. It seems impossible. But then again, flight seemed impossible to a species without wings. Splitting the atom seemed impossible to a species that thought matter was solid. We are wrestling with the angels of geometry and the demons of quantum mechanics, hoping that in the struggle we find a loophole that the universe forgot to close. The feedback screech of the vacuum is loud in our theories. The blue sheet of radiation stands like a firewall at the speed of light. But until we build the machine and turn the key, we will not know for sure if the explosion is inevitable. We are left with a universe that is tantalizingly constructed. It gives us the math to dream of the stars, but the physics to keep us grounded. It is a cosmic tension that drives our science forward, a perpetual engine of curiosity fueled by the very limits that constrain us. This brings us to the final horizon. The journey through the physics of the warp drive, from the bending of space to the screaming of the vacuum, leaves us with a profound realization. We have spent decades banging our fists against the glass, demanding that the universe let us out. We've treated the speed of light as an error, a bug in the code, an unfair restriction imposed on our ambition. But perhaps we have been looking at it the wrong way. The speed limit is not a cage, it is a load-bearing wall. If we could easily change the speed of light or bypass it with a toggle switch, we would not just be changing a travel regulation. We would be pulling a thread that unravels the entire sweater. The speed of light is woven into the fine structure constant, the number that dictates how electrons orbit nuclei. It determines the strength of the electromagnetic force. It dictates the rate at which stars burn and the stability of the atoms in your blood. A universe loose enough to allow easy warp travel might be a universe too unstable to allow for life. The rigidity that traps us is the same rigidity that allows us to exist. We are made of the same rules that bind us. So, where does this leave us? If the Alcubierre drive remains forever in the realm of mathematics and the wormhole remains a lethal instability, are we defeated? Is the human story destined to end in this solar system? The answer is no. The impossibility of the shortcut does not mean the journey is impossible. It only means the journey is long. It means that the galaxy is not a subway system to be traversed in minutes, but a vast ocean to be crossed in epochs. This realization forces a shift in our species psychology. We are addicted to speed. We want the stars now. We want to see the moons of Endor and the rings of Saturn in the same afternoon. But the universe operates on a timescale of billions of years. To conquer the distance, we may not need better engines. We may need better patience. We may need to rediscover the art of the long voyage. The future of interstellar travel might not look like the sleek, glowing ships of our movies. It might look like a hollowed-out asteroid, spinning for gravity, drifting through the void at a modest percentage of light speed. Inside, generations of humans would live, love, and die, tending to their hydroponic gardens, teaching their children about a blue planet they will never see and a destination they will never reach. They would be the baton carriers in a relay race across the dark. The generation ship is a solution that violates no laws of physics. It requires no negative energy. It requires only the will to plant trees under whose shade we shall never sit. Or perhaps the solution lies not in moving the body, but in suspending it. The technology of cryosleep stopping the biological clock would turn a 1,000-year journey into a single night. The silence of the void would be matched by the silence of the crew, sleeping in frozen coffins while the ship's computer watches the stars drift by. In this scenario, the speed limit becomes irrelevant to the traveler. If you are asleep, it does not matter if the trip takes a week or a millennium. You wake up at the new sun, young and ready. The barrier of time is defeated not by speed, but by stasis. There is an even more radical possibility. We are creatures of meat and bone, evolved for gravity and atmosphere. We are heavy, fragile, and short-lived. Maybe the stars are not meant for biological bodies. As we merge with our technology, we might find that the ultimate astronaut is a digital consciousness, a human mind uploaded into a laser beam. We could transmit ourselves at the speed of light, the absolute limit to receiver stations built by robotic probes sent out centuries ago. We would ride the photons themselves, crossing the galaxy instantly from our perspective, arriving at a mechanical body on the other side. In this form, we would inhabit the light, we would become the signal. This perspective transforms the great silence of the universe from a frightening mystery into a comforting logic. If warp drives are impossible, then civilizations do not zip around the galaxy in invasion fleets. They sit quietly on their home worlds, or they expand slowly, patiently, like coral reefs growing in the dark. The silence is not emptiness. It is distance. It is the buffer zone that keeps civilizations from colliding, allowing each to mature in its own time, protected by the vastness of the void. The speed limit is the quarantine that prevents cosmic war. It is the peacekeeper of the Milky Way. As we look up at the night sky tonight, let the frustration fade away. Replace it with awe. The stars are far. They are incredibly, terrifyingly far. And that distance makes them precious. It makes every photon that reaches your eye a miracle of survival. The universe is not a small room. It is a cathedral of infinite proportion. It is designed to be looked at, to be wondered at, and perhaps, one day, to be walked across, step by slow step. The warp drive remains a beautiful dream, a testament to the fact that our minds can travel to places our bodies cannot. It is a working theory that pushes us to understand the fabric of reality. But even if we never build it, we have already won. We are the species that stood on a rock and measured the curvature of space. We are the species that dared to ask if we could break the rules. So as you drift off into the dark, remember that you are a child of this universe, subject to its laws, protected by its limits, and invited to explore its mysteries. The engine may be theoretical, but the dream is real. And in the dream, the speed of light is just the beginning. This channel is dedicated to exploring the deepest questions of the cosmos to help you find rest in the wonder of existence. We are building a library of the unknown, one theory at a time. If you found comfort in this journey through the impossible, and if you want to be part of our silent crew as we explore the next mystery, make sure you are subscribed. Click the bell icon so you don't miss our next departure. The universe is vast, and there are many more theories to explore before we sleep. Good night.